So we're going to be setting up Deepseek to run locally on your machine or PC today. So we're going to start off by firstly having to download an application called Ollama. So you can go to ollama.com/download, and then from there you can select the operating system of your choice. Just note that we are doing this for Windows today. So /Windows, you'll then download Ollama. Once downloaded, you'll then need to install it. You simply just execute the exe, and as you can see, it'll install, and then once installed, the installation window will just disappear. Now that Ollama is installed, we can then open Command Prompt or PowerShell. It's up to you. Once open, we can then get Deepseek R1 up and running. So to do that, you'll need to type in the following command: Ollama run Deepseek with a capital D and S -R1, that's with a capital R, :7B. So that's the model version you're going with. So I'm using 7B and 8B. There are smaller models you can use. Both 7B and 8B are within 5 gigs in size, but there are even smaller models like 1.5B. Once you've decided on the model version of Deepseek you want to use, you can then press enter. What Ollama now does is check if you have the model already on your PC, in other words. So it's checking that the model that you specified is already downloaded. If it is not, it will then download the model you have specified. Once downloaded, it will then initiate the model where you can then start communicating with the AI directly in the console. Note that I tested these Deepseek models with and without GPU acceleration. I'm specifically using 2 older Nvidia GPUs. What I also found out is that to be able to use GPU acceleration without having any extra steps, you will need specifically an Nvidia GPU that supports at least CUDA 5.0, which means you can use non-RTX Nvidia GPUs. So if you have a GTX GPU lying around, you could potentially use it to accelerate the Deepseek model running in Ollama. Obviously, as long as it supports CUDA 5.0, as previously mentioned. You can use AMD and Intel GPUs, but that requires some additional steps. So the GTX 1060 I tested with is the 6 gig version, and the GTX 1080 has 8 gigs of VRAM. Note that both the 7B and 8B models were both able to be fully loaded into both GPUs VRAM. I thought the GTX 1060 would end up spilling over into system RAM, but surprisingly it didn't. But it was a tight fit, in my honest opinion. I think I was sitting around the 5.6, 5.7 gigs of VRAM. And in certain scenarios, I can imagine it actually spilling over into system memory, specifically with the 8B model. Also note that you don't have to have an Nvidia GPU to run Deepseek and Ollama. It can run pretty much off your PC CPU and system RAM. But obviously it'll just run a little bit slower. I ran it on a Intel Core i5 12400F with 32 gigs of DDR5 memory running at 5600 MHz, and it ran fine. It obviously wasn't as fast as running it with one of those GTX GPUs, but it ran well enough. Alright, let me now show you how it ran on the GTX 1060 and 1080 with some questions and stuff I did messing around with the API to just see how the GPUs responded. So keep in mind though, both GPUs were installed in different systems. The GTX 1060 was paired with an old Intel Core i7 4790 with 24 gigs of DDR3 memory running at 1600 MHz, and the GTX 1080 was paired with an old AMD Ryzen 1800 with 32 gigs of DDR4 running at 2666 MHz. So by just looking at the GTX 1080's performance here and live stats as we are asking it questions, you can see the VRAM is sitting at 5.9 gigs, hence why I said earlier it was quite a tight fit for the GTX 1060. Utilization seems to jump between, let's say, 70 and 90%. The GTX 1080 itself has 2560 CUDA cores, where the GTX 1060 has exactly pretty much half of that, coming in at 1280 CUDA cores. So what I noticed with the GTX 1060 is utilization only was jumping between, let's say it was roughly as I can remember, between 40 and 60%, where the GTX 1080 is jumping between 80 and 90%. And I can only assume that's due to the CUDA core count. So let me now show you the Angular Deepseek chatbot application I coded. I'm going to just run you through the application itself. I'll show you all the code at the end. So right now we're also running this on the Intel system with the 12400F. So please note we obviously don't have any GPU acceleration here. As you can see, I'm just asking it a few random questions. Note that the way in which I coded this web application, it continues the chat in the current session. So basically, in other words, as long as the page does not load, like have a reload, the AI is aware of the previous messages and responses in the conversation. So in that way, you can continue a conversation that it can reference previous questions and answers to obviously give it more insight when it's answering the next set of questions or question. All right, let's now jump into the code. So firstly, obviously, you're going to have a Angular project already created. Just a no standalone Angular 19 project is what I generated. Keep in mind, some of the stuff you'll see, I haven't kept to like traditional Angular coding standards for some of the stuff. It's just easier, makes it easier for me to explain certain concepts and properties without causing any confusion if you see a certain property as an individual item and not part of, say, like a bigger object. Anyways, let's jump into the code. So firstly, in the app folder, I've created two additional folders, the areas folder and the shared folder. So the areas folder just contains the actual chat component itself. And then in the shared folder, I've just got a models folder and a services folder. All right, so we're going to start with the models. So firstly, let's open the Deepseek parse object. So this file basically contains the interface which represents the data structure of the parse object you will be posting to the local Ollama web API, so that you can obviously communicate with the Deepseek instance running there. So we have in the Deepseek parse object itself a model, max tokens, temperature, messages, and stream. So model is a string, max tokens is a number, temperature is a number, messages is a message array, which actually represents the interface message, which just contains two properties. You've got a role property of string and content of string. All right, then you have the stream, which is just a bool value. So the model just indicates to the Ollama API as to which model you're using. So like Deepseek, B7 or B8, etc. Then you've got tokens. So a token in reference to an AI basically indicates how detailed a response, I guess, could be. In short, it's a bit more to that, but basically in that context. It also sort of determines how long a response should be. Then for temperature basically indicates to the AI how creative it can get. So you usually work between 0.1 and 1.0. So the lower you go, the more the AI keeps to the point. In other words, it keeps to what you're actually asking it. It doesn't sort of go on a tangent. So in other words, if you go higher, it gets more creative and off topic. Then you have the messages array. So the messages array just contains all the messages you've sent the AI along with its responses. And then stream to indicate whether it streams the response, so it like chunks the response, or if or you wait for the entire response to come back. All right, let's now open the Deepseek response object. So this interface represents the response object we'll be getting back from the web API. All right, so we have a model created at a message, and then whether it's completed or not with a done Boolean. So the message is just the response from the API. You've got role and content. So content's the actual message from the API, and role just indicates whether it's a user message or if it's an AI message. So for user, role would actually have the string of user, and if from the AI, role would have the value of assistant. And this obviously represents one instance of a response. You're not going to have multiple messages and content in here. as it's just the message that pertains to the current question you've asked the AI itself. Let me now go to the services folder and open the API service. So basically this service is just going to allow us to make requests to Ollama's local web API, but stream-based requests. So also just note all the imports, and also just keep in mind there is a reference to the environment.api URL. So let me just quickly show you that before we walk through the service. So I've got this environments folder here with this environment.ts file, TypeScript file. In here, I have an API URL. It's just the base URL to Ollama's web API. So you just come and set it here, that we don't have to set it every time we make a request to this thing. Or sorry, every time we use the service. So let's go through the service. So this is the function to send a post request and stream the data from the HTTP response. So firstly, we pass it a string for the URL, for the specific endpoint we want to hit, and then the data we want to post to the request. Okay, we then just set the headers here for the HTTP request, and we're specifying that it is that the content type is of JSON. All right. This post here then sends a post request to the specified URL as specified in the comment here with the provided data. The response type is set to text, and that's obviously just so that the response that comes back is just plain text. We then have observe, and that allocates, well, we're observing events, right? So this allows us to observe the progress in the request and the response. So in other words, this is what's going to allow us to chunk the data, right? Then we have report progress, and this enables us to get the reporting for the request, and this is what allows us to basically handle how the chunking is working. We know whether it's still in progress or if it's completed. All right. And then this is obviously just the request itself, and I've explained all these props here. We then have this handle error method. This is only if we have any issues here where we catch an error, and I just log the error to the console, and then we also throw an error. This actually isn't necessary, or it's deprecated, but that's just how I usually code. All right. Alrighty, so that's the API service out the way. You can ignore the local storage service. I'm not using that as of yet. This project is a work in progress. So note, I will not be releasing the code. I will only release the code to say GitHub once I've actually completed this project. I mean, you can obviously follow along and copy all this code if you feel that you want to do your own thing, but so please do not ask me for the code. I will release a video for when the code is available on GitHub. All right, let's now go to areas, and let's go to the chat folder and have a look at this component, that being the chat component. So for this Angular application, I went with CSS. I usually use Sass, but I was just, as I say, keeping it straightforward. Not that Sass is complicated, but anyway. Now let's have a look at this component. We're going to start with the chat component itself. So if we take a look here, okay, well, this is where I mentioned earlier, I've separated certain properties which I then bind, or should I say map, to the pass object itself. And the reason I've done that is it just makes it easier for you to sort of see what property is what, instead of having these properties for the chat object itself bound in the template, where I'm just doing mappings where each one of these components here, not components, sorry, each one of these variables here are then mapped to the template, and then I map those then to the object. So it seems a little bit backwards. I've just done that purposely, just so that everything is isolated here, and I'm not having this .chat object all over the place. All right. So firstly, please note the imports. Please note the standalone is false, the selector, and then the templates and the style URLs. All right. So not that I'm actually using the selector, because what actually happens is that the default route routes to this component by default, in other words. So let's actually have a look at the app routing module. So as you can see, there's our route. If the path is empty, it must go to the chat component. So that gets that out the way. Let's now go back to the component. So firstly, I have this view child here for the text area. This is an HTML element. What I'm basically doing is when we get a response back from the Ollama web API, I want the text area to scroll down every time new text comes in, and that way you don't have to keep scrolling down in the text area to see what is actually being said, as it'll do it for you. Okay, then below that we've got the text area content. So this is the actual string or date, the text that is mapped to the text area that shows basically the AI's responses. We then have the Deepseek LLM. So this is just represents the model that I'm telling Ollama to use when I'm making the API request. We then have the max tokens. I explained what tokens were earlier, the temperature, and keep in mind I've set default values here and must stream are set to true. And then we have content. All right, so the content is actually what we send, what we type in to send to the AI. All right, then we have the chat object. So this is the pass object that will be mapping all these properties to. Now keep in mind all these props here are bound in the HTML template. So we also obviously need access or an instance of the API service. So hence why we are initiating an instance of that in the constructor. We also implement on init and after view init. So basically we have the scroll to bottom method, and this is the method that basically forces the text area in which the AI responses get pasted or bound to or shown in to scroll down to the bottom. So I just initiate it just so that in the future, if you had to load in, say for example, an entire message array, it would scroll to the bottom based on all the context that's in there, right? Or content. All right, then on the ng on init, basically what happens here is I bind all these, I allocate all these default values to the pass object. All right, so I'm just doing a bit of mapping here. Keep in mind this is the object that gets passed to the Ollama web API. Okay, and I just do that on initiation. When I send a question, I then do it again. Ideally, I guess I could just do it here every time. This was when I was testing with no content. All right, so what I was basically doing is I had a hard-coded question in there. I hadn't written any of this yet. I was basically saying on init, just bind all the dummy data that I want to allocate. So then when I send the question, everything, there's already data that's being passed. All right, we then initiate an instance of the message. Now earlier I spoke about an assistant role and a user role. So the user is us. All right, so basically what's happening here is I'm saying for the message, the role is us, so that indicates to the API that we are sending a message to be consumed and looked at in the back end on their side. And then obviously for the content, this is just our actual question or text that we want to send it. And then what basically happens here is I push this message into the messages array. Okay, we then make that post stream request. There's the actual rest of the URL that's the actual endpoint path that we are passing. And then there's our chat object. All right, and then basically what happens here is we then obviously wait for our response, and if the response type is download progress, this basically indicates that listen, there's still more data to come. This is just a chunk of the data that we have for you. We then process that chunk. So what I essentially do is I clear the text area, the response area, for the text area where the AI for the AI response, because what happens is we don't want to, every time it chunks, we get the full object in chunks, right? And we're building it up. So we don't want to keep duplicating the text. We just want to basically clear what's there and allocate the new object that's been updated. Okay. We then iterate through the response string by breaking the response text up into a string array by new line. So basically, in other words, if it comes through and there are line breaks, we want to break each line up into its own string. And then we allocate it to an array. We then iterate through that array, and then we map that JSON string that's come through to an instance of the Deepseek response object. All right. Then from this response, we then update the text area context with that content. All right. So this is now obviously there's more content that's come in, so we need to get it allocated to that, so we can obviously see the rest of the text or message that has come back, in other words. So say, for example, you say, hello, how are you? And it says, hello, I'm great, thanks. So if we get the first word of hello, comma, thanks, I'm great, you might get each one of those words as an individual chunk. So obviously what we are doing is we're appending that to the text area content. All right, then basically what happens is, if it's complete, so in other words, if we come back here and it's not download progress, right? The event type is response, which means that it's completed. We then indicate with this completer true or false. All right, if it is complete, then what happens is I take the entire message, I create a new message instance and say, listen, here's the full response from the AI, and the role of the AI is called assistant. I then push that into the messages. This is what allows us to continue and maintain a conversation. All right. Then once that's all done, I just say scroll to the bottom. And then if there is an error, I obviously log it to the console. So that's pretty straightforward. I'm hoping that makes sense. All right, let's now look at the HTML template for this component. And just before we jump into the chat component template, I just want to quickly run you through the app modules so you know the declaration and imports. So we have the chat component, obviously, and then for imports we have the HTTP client module, the browser module, the forms module, and the app routing module. These are all the modules that make our application work. Alrighty, let's now get back to the chat component template. So if I haven't mentioned it already, I am using Bootstrap 5.3.3. So as you can see, I'm using some Bootstrap classes here. I'm not going to obviously show you how to install Bootstrap, assuming you know how to do that. Otherwise, it's something you can Google and find how to do rather quickly. All right, so what I've got is for the nav brand, I've just got what I've called it, Deep Web Chat 1.0. I have also got some list items here, which for new chat just reloads the page, therefore resetting all the default values due to that ng on init, and then it obviously maps those. For stop chat, I haven't actually done anything with yet. I then just have these two headers here. Here's the actual input for what type of model you want to work with. All right, then we have the input for the number of the max tokens for that binding. Then we have the temperature binding underneath to the side of that, or below that, should I say, for temperature. Then we have the response area, so the text area where we get all our responses basically allocated to when we are streaming that data from Ollama's local web API. Then we have the user input. All right, I have added 2 additional disabled props here to the text area element and the button element. Basically what this does is it just disables the submit button and disables the user input text area when you are submitting a message, and it's rather simple. As I say, I've got a working boolean, and then basically in the code itself I set it to true and false accordingly, which will enable and disable those 2 controls. Alright, well, I hope you enjoyed this video. It's a bit of a long one. I do apologize in advance if my explanations aren't great. I am doing this on the fly, and I did try assist myself with a couple of comments here, but re-looking at these comments, they're not that detailed. Anyways, I hope you enjoyed the video. Please consider subscribing. Keep it clean, keep it tidy, and I'll see you on the next one.